Superior Essex manufactures its copper communications cable products in multiple facilities throughout the United States. In these locations, we produce thousands of different copper cable designs, ranging from outside plant copper telephone cable to high-performance premises cables. In this video, we will guide you through the principal manufacturing processes for both outside plant and premises copper cables. The first step in the manufacturing process is called rod breakdown. Copper is received by each plant in 5,000-pound coils of 5/16-inch diameter rod. The large rod is continuously drawn through a series of diamond dies that gradually reduce the size of the copper to 10 or 12 gauge. A special lubricant is used during the process to reduce friction between the dies and the copper and to provide a smooth, high-quality wire. The output of this process is stored in large vertical coils called stem packs. The stem packs are transferred to another drawing operation that further reduces the wire gauge to a size required by the finished cable. In this second drawing step, the copper is also annealed, which is a softening process that is accomplished by passing a large electrical current through the wire for a fraction of a second and then cooling it with water. During this phase, the diameter of the copper is carefully controlled using laser measuring heads. The annealed copper conductor now enters the insulation process, where one or more extruders apply a plastic coating to the wire. This process is continuously monitored and controlled to tolerances of 10,000ths of an inch. Samples are taken at regular intervals to test the copper and insulation against tensile strength specifications, elongation, compression, and strip force. Exiting the extruder, the insulated wire quickly enters a cooling trough that allows the plastic insulation to harden before the wire is wound onto reels prior to the next operation, twisting. The vast majority of copper communications cables are designed around the concept of twisted pairs. Twisting helps reduce the effect of crosstalk interference. Each pair in a cable bundle has a unique twist length, from as short as 0.25 inches on Category 6A cable to as long as 6 inches on some outside plant cables. In the twisting operation shown here, 25 pairs of wires are twisted simultaneously, each with a different twist length. The multiple twisting pairs are then combined to form the cable unit in the next process called stranding. Here you can see how the pairs are fed through multiple faceplates to carefully control pair position as the wires are stranded or twisted to form the cable unit. The stranding process is similar for 4-pair premises data cable, but with much more precise controls. Here we see the stranding of a Category 6 cable. A separator tape, used to further improve crosstalk performance, is inserted into the cable during the stranding process. At this point, we have what is called a cable unit. For small cable designs, the next step in the manufacturing process is jacketing. For large cable designs, multiple units are first grouped together to form a multi-unit cable core in a process called cabling. Superior Essex manufactures copper cables with as many as 4,200 pairs of wires. For very large cable designs, a rotating closer is used to group and twist several multi-unit cores together in a precise manner, using color-coded binders to identify each subgroup of copper pairs. The final phase of copper cable production is the jacketing process. The materials used for the outer cable jacket are chosen for the intended application of the copper cable. For outside plant copper cables, Superior Essex typically uses black polyethylene or UV-grade PVC. For premises cables, varying grades of PVCs and fluoropolymers are used for the jacket, depending on the application of the cable and the flame safety rating required. Throughout its facilities, Superior Essex utilizes over 20 different jacket materials to manufacture its more than 5,000 different cable products. The jacket extruder is simply a scaled-up version of the insulation extruders we saw earlier. Molten plastic is extruded at high pressure and formed around the moving cable core. Shielding, ripcords, water-blocking compound, and armoring may also be applied during this process step. After the cable exits the extruder, it passes through a long cooling bath and then is passed through a laser micrometer to verify that its diameter is within specifications. If the finished cable requires a double jacket and double armor, it will make a second pass through the jacketing process. The cable is printed just before it is put into its final package. For large outside plant cables, Superior Essex utilizes a hot foil printing process that leaves an indented print on the jacket. For premises cables, high-speed inkjet printers are used. Each of our 1,000-foot packages of premises cables is also printed with quick count footage markings, a process we pioneered several years ago. The completed cable is then wound onto a reel or into a coil. The coiling process requires very precise tension controls to ensure that the cable will not kink as it is pulled from the pop box packaging. Before the cable is approved for shipment, it must pass final test inspection, where it is tested against a large set of mechanical and electrical performance specifications. Once the cable passes all tests, it is ready for shipment, and a record of all tests are retained and analyzed, which allows SPSX to make necessary adjustments to further perfect its cable performance. Each of the thousands of different copper cable designs made by SPSX follows a manufacturing process that is patterned after what you have just seen. It is a process that has been continuously refined over a span of 50 years of producing the broadest portfolio of high-performance communications cable products in the industry.